over here we have another derivative problem. We want to find the derivative initially and then use it to determine where the tangent line is horizontal, as well as find the equation of the tangent line at the given point. So the function we're given is f of x is equal to x squared minus 6x plus 4, and the given point is going to be 2, negative 4. Okay, so working through part A first, we know that the derivative, or f prime of x, is just equal to the limit of the difference quotient. So we have, if we just plug this into the difference quotient, we have x plus h squared minus 6 times x plus h plus 4 minus x squared minus 6x plus 4 all over h. We can simplify this down by expanding x squared plus 2xh plus h squared minus 6x minus 6h plus 4 minus x squared plus 6x minus 4 all over h. We have a lot of terms here, so let's combine like terms. We have positive 6x and negative 6x. That gives us 0. We have positive 4, negative 4. That also gives us 0. We have positive x squared and negative x squared, which again give us 0. So now we're left with just 3 terms here. We have 2xh plus h squared minus 6h all over h. And we can tone this down by canceling out the h's to give us 2x plus h minus 6. But again, remember, we're not done. We want to find the limit as h approaches 0. So when we use direct substitution now, we get 2x plus 0 minus 6, which is just 2x minus 6. Okay, so that is going to be our derivative. So this is part A, f prime of x, our function, or not our function, but our equation that gives us the kind of formula for the slope at every point along this function here is 2x minus 6. Now we want to use it to determine where the tangent line is horizontal. So this gives us the slope of the line at every point on that function. And we want to find the point where the slope is going to be equal to 0, because a 0 slope means that the line is going to be horizontal. So we want to find the point where the tangent line is going to be at a slope of 0. So we're just going to set this equal to 0. We're going to do 2x minus 6 is equal to 0, because 0 is going to be our desired slope. And what this will give us is this will give us the x value of the function where the point, the slope will be 0. So if we solve this, we get 2x equals 6, or x equals 3. So if we plug this x equals 3 back into our original function here, we get 3 squared minus 6 times 3 plus 4, which is 9 minus 18 plus 4, which is equal to negative 9 plus 4, which is equal to negative 5. So this is going to be our y value. We have our x value and y value. Now we have a coordinate, 3, negative 5, and this is going to be the point where the tangent line is horizontal, because the slope at that point is going to be equal to 0. This is a quadratic function, which means that we have a graph that's similar to this. So if we want the point where the tangent line is 0, that's going to be at the vertex, which is right over there. And what we know about quadratic functions is that we could just do negative b over 2a, which is going to be equal to 6 over 2, which is also equal to 3. So that's another way to find the vertex, but this is kind of a universal method to find the equation of the tangent line, because negative b over 2a only works for quadratic functions. So now we did part A, we did part B, now let's move on to part C. Find the equation of the tangent line at the given point. So essentially what we're going to do is we're going to plug this into the derivative to give us the slope of this particular line. So if we plug in 2, we get 2 times 2 minus 6, which is equal to 4 minus 6, which is equal to negative 2. So this is going to be equal to the slope. So we have a point and we have a slope, which means we can plug it into point slope form to figure out the exact equation of the line that is tangent to this point. So the formula once again for point slope form is y minus y1 is equal to m times x minus x1. So that's going to be y minus negative 4 is equal to negative 2 times x minus 2. And that gives us y plus 4 is equal to negative 2x plus 4. We subtract 4 from both sides and they basically just go away. Y is equal to negative 2x. And that is going to be the equation of our line that is tangent to the point that's given to us.